right, I guess we're at the top of the hour, a minute after, so let's go ahead and get started. Welcome to the AskTOM Office Hours for EMEA for Database and Memory. And my name's Andy Rivenes. I'm a product manager with Database and Memory. And today we have Markus Kissling, who's also a product manager for Database and Memory, presenting a question that he said he was asked at the latest DOAG conference and some other events that he's been at. Do I need twice the memory with Database and Memory? So with that introduction, Markus, take it away.
Yes, thanks, Andy. Welcome to our session. As Andy mentioned, the question arises quite often in the last conferences or meetups. Do I need twice the memory when I use Database and Memory? Yeah. So let's start with a short recap of Database and Memory. We have in former times we had to decide either use a row-based database or column-based database. Yeah, and row-based is good for transaction, column-based for analytics, and our, let's say, Database and Memory option takes the best of both worlds, because we can use the traditional buffer cache for the transactions. And on the other side, we have this new pool in the SGA, System Global Area, the in-memory column store for running analytics. And this is our, let's say, our unique, our added value, we are unique at the market with this architecture, and it's seamlessly built in the database. And we support all enterprise features. Since day one, RAG Data Guard Flashback, this is very important. And we will see this seamlessly built in the database in the next couple of minutes when we talk about I show you some demos. So let's start with my environment. I run a VirtualBox environment with Oracle 19c, and also I already activated Database and Memory. So let's run SQL Plus. I have my star schema benchmark, and in this schema we have a line order table, it's a fact table, and 4 dimension tables. In this demo, it's about the line order table, because it's easy to demonstrate that we only need very less memory. Yeah. So first is that I populate the line order table into the in-memory column store. This is because when I alter the table in memory, I do not enter an in-memory priority. So when I first query the table, this means I populate the table to the in-memory column store. Yeah. So let's take a look here. Here's the worker and background process called Aura W00. This means this process is responsible to load the blocks from disk, flip it 90 degrees, pivot it, and populate a column store. This takes a minute or two. So we can already take a look how much space this line order table let's test it. So line order is completely populated in the in-memory column store. We use the IM segments, $IM segments view. And the first question is how many blocks are involved with the table on disk, with this line order table. And then I can check with this script. So I query the user segments, and we have about 155,000 blocks and about 1,216 megabyte on disk. So the question is, how much space is required from the buffer cache? So we see that we only need 15 blocks. With each block has HK. It's only a few blocks are required to synchronize the buffer cache with the in-memory column store, and 15 blocks is not much. So
that space is just taken up for what the buffer cache manages from a full table scan, right?
Yes. Yes.
So we don't flood the buffer cache with all of the blocks from the line order table, because that would push out if you had other workload. That's nothing new with Oracle database. Do you also have a query that shows how much space is used in the column store, or am I jumping ahead?
Yes, I have.
Did I get out of order there? If I did, just say something. I'll hold my question.
Yeah. So we need in the in-memory column store, we need only 586 megabytes. Yeah. With the default compression, this is for query low. Yeah, this is only a lightweight compression for DML or for query for queries. Yeah. We've also much higher compression ratios, like for capacity high. This is I will show in a later example. This means we even compress the in-memory column units in a very good, in a very efficient way, that we only need half the memory from disk to populate the table in this in-memory column units. So we have seen we don't occupy space in the buffer cache and in the in-memory column store. And this was our competitors often claim that we need with database and memory twice memory, and this is not true. And this is what we talk about today, because we are very efficient, even when we run a mixed workload. For example, when I run a single query, let's say an index access query. Sorry. So this is, let's say we have an index on the order key column, and this is a single row access. Yeah, it's a B tree. So we see it in the execution plan, and this shows us that database and memory is very good in mixed workload environments. Yeah. If you have transactions, we use the buffer cache. And if we run, this is the next example, if we run analytic queries, then we use the in-memory column store.
So you ran a query, you didn't have to tell Oracle anything. You just ran the query, and the optimizer parsed the query and, based on cost, decided to access the data through an index, even though the line order table is fully populated in the column store.
Exactly. Yeah.
So then that allows you to do OLTP transactions just like you would without in-memory enabled or any of the data populated. And
exactly.
So it's truly a cost-based decision. And then
exactly.
Now, if you were to, can you query just for my own curiosity, can you query that buffer cache query you had again?
The same one?
Yeah, or am I getting, if I get you out of order, just let me know. We didn't rehearse this because this is office hours. So, but if you run that again.
Yeah.
It's always dangerous to do something out of, I meant but now can you show us that your $BH query, you know, the one that does looks at how many blocks are in the buffer cache?
Yes.
The one you ran at the very beginning?
Yes.
Because we should see a few more. So we see a couple index blocks.
Yes.
And then you see but that's clearly not anywhere near as large as the total size of the line order table, right? So we're not
exactly.
So one of the beautiful things about Oracle database is that in the row store, the buffer cache, it's very efficient at caching just the data required, and so clearly we're not using as much memory in the buffer cache as we would to cache the entire table. So so we've already debunked the twice as much memory, right? Because we're not we're using a fraction of the memory for the row store. And then we showed that we're only using about half the memory for the column store when you did your original query, right?
Yes.
So we're way better than twice. We're not even one time at this point. So that's cool. So then what are you going to do? You're going to show us the column store access?
Exactly. This is the next step.
Okay. That's fine. While you're doing that, let me let everybody know that if you do have questions, feel free to type them in the chat window. I have everybody muted right now, but if you do have a question about this or anything else with database and memory, which I don't think I said at the beginning, feel free to put it in the chat window. I think the demo isn't going to take super long, so we do have time to answer any of your database and memory questions. But of course, if you have questions about the demo, feel free to ask those questions as well, and I'll take a look and repeat them to Markus so he can answer those questions if you have them. Yeah. All right, sorry, I just had a little bit of business there.
Yeah. So the query was, I am a memory column store query. And this is a query we see we had with an aggregation with a sum max, and we have two predicates, ship mode and order priority. Then execution plan shows that we run against the column store.
So now the optimizers decided to run the query against the column store.
Exactly.
You didn't have to hint it, right? You just ran your query.
Yeah. I just it's without a hint. Yeah, this is optimizer cost decision. Right. So hit enter, then we see the statistics, the session statistics. We run against all the rows. Almost 12 million rows. We can also take a look now at the buffer cache, and you see we have still only 16 blocks, buffered in the cached in the buffer cache. Yeah, this means we don't need space from the buffer cache for this query. Yeah, running against the column store.
Right.
And so this shows us.
Sorry, I'm just going to clarify. So you didn't change any of the space required out of the buffer cache because the query ran against the column store, and that column store space doesn't change because once we populate the object, it stays populated in the column store. It's not a cache, it's a store. And we already showed that you're using about half the memory, or maybe a little less than half actually,
Yes.
because of the compression. So,
Yeah.
and then you're able to run queries based on their access path. So the optimizer decides on cost, accessing maybe an index, accessing the column store. So that kind of, I'm just trying to clarify all of what you've shown so far.
Yeah, exactly.
Okay.
I mean, this is, as we have seen, we don't use, we are very efficient when we run queries, analytical queries, or queries which are more OLTP type queries. So we don't waste memory. Yeah, that we have to use more memory than needed. Yeah. And this is what today's session is about. Yeah, to show you guys that Oracle memory does not need twice memory. Yeah.
Right.
Because when we take a look at the compression level, if we, for example, use a higher compression than the default one, which was for query low with 554 megabyte and a compression ratio 2.2. When we use, for example, this capacity high, then it's about 277 megabyte and a compression ratio about 4.3, which is much higher. But we have to keep in mind that this compression needs more CPU, because we have this zip. We zip this column units also, and we have to unzip the column units. But
so just for fun, again, since we didn't, I'm going to interrupt you again. Just for fun, since we didn't rehearse this, are you going to repopulate the line order table with compress high and run it again? Run the query again?
Capacity high, yes.
Capacity high, sorry. Yeah,
yes.
That would be kind of fun. I don't know if you were planning on doing that, but we have time. Is it?
Yes. No problem. Yeah.
Okay. I think that would be kind of interesting to see then. Did you put, is timing, wait a minute, before you do that, is timing on the query above that you ran against the column store?
Pardon?
If you scan up, if you just go up above, just scroll back in the window there a little bit. Do we have timing set on that query?
No, I don't think so. Well,
all right.
Yes, we have here.
Okay, cool. So now let's do it now, if you don't mind, if you could say alter the table no in memory and then repopulate it with compress for capacity high, mem compress for capacity high, and then run it again just to see. Now we did this in a previous session, but just kind of, since we're being kind of ad hoc here, it'd be kind of interesting to see the difference, because people, I know when I do talk to customers, the people kind of always are worried that, oh, if I go higher levels of compression, it'll be so much overhead. But we've already seen that you're going to get what over 4x additional 4x compression. So that's about twice what you're getting with normal compression.
Yes, exactly. Yeah.
So let's see what happens. I mean, that's what this is all about, right? Just try things out and see how this goes.
Yes.
So now, if you flip over to that top session, we should be able to see the background processes. Oh yeah, you got to access it. No priority.
But I had also type in an priority. So I need first to access the table, and then we see here the.
Now if you go to your top
thread.
There you go. Yeah, that's always kind of fun to be able to see the population going on.
Exactly. Yeah. Take some half a minute, and then we need CPU. That's because this is a CPU intensive operation, but I think the outcome is very good. Yeah, because you save a lot of memory with a higher capacity
one time though. I mean, just to populate.
Yes.
Yeah.
It's only for the population. Yes, exactly. I hear my fan. Yeah. So
well, yeah, you could
it
point
works.
that for most people on real database servers, this is much more trivial than on trying to do this on laptops. So
exactly. Now we finished.
Yeah.
And then question was, the query was, I am CSQ.
Yeah, the column store, right?
No, it's
Whoops, no, go back and show how much. Well, okay, so it ran the same amount of time, but it was pretty fast.
Almost, yeah.
Okay, so I thought you were going to run the space query first, but
okay, that's also important.
That's all right. So all of the same, but it's a tenth of a second or so slower. And then for how much space did you save? So I think we already know, but let's take a look at the real example here.
CSP. It's 273 megabyte. It's
what did you have
half.
Here? Is that what you had on your slide? So it's like 4 times.
Yes, 4 times.
Or almost 5 times actually.
4 times, yeah.
I can't add, but 1.2. Yeah, okay. So that's a real possibility, because I talked to people. Actually, I was talking to somebody yesterday, a customer yesterday, about the fact that very often our customers don't have tons of memory, or I should say terabytes, a lot of excess memory in their database servers, and so higher levels of compression really are pretty feasible. Granted, this is just a small test case, but not only we do less than 2x, which your premise was that, a question that people ask you, or 2 times, it's way less than 2 times. It's not even close to 1 time, right? So
exactly,
that's pretty compelling, I think.
And we have a customer, they have a database 56 terabyte, and in memory column store is about 250 gigabyte. And they put the last 2 years, the last partitions of the last 2 years, and they're very happy. It's an Exadata A-track, and it's running. Yeah, they run the analytics, the warehouse, the dashboards. Yeah, 3 times till 10 times faster, and they also use these higher compression ratios for some tables, and it's very good for them. Yeah.
Okay,
we don't need that much memory like a pure in-memory database needs, because we have this. Let's say the charm is that we can combine, disk, Exadata storage in memory, then the different levels of compression. Yeah, it's, I think, very, very good for the customer. It's a good benefit.
So, Markus, let me interrupt you one more time. So we're going to go off script. One last. I got one last one for you. How about if you run that analytic query, but put a no in memory hint in there, or maybe do an alter session set in memory query disabled, just to show the speed difference in accessing running that same query against the buffer cache versus in memory, because even at the compressed high, we saw it took like 3/10 of a second, and so and then because that's the argument I usually use, is that I say that, well, yeah, maybe it takes a little bit extra at capacity high, a little bit extra CPU to decompress the IMCUs, but you're getting such better performance that the trade-off for that 4x compression rate is, seems like it's noise. And so let's just, if you don't mind, if you
no problem. I just had a typo. So
what we're going to do is we're going to purposely tell Oracle database, don't use the column store, even though it normally would. And we're going to run Markus's analytic query one more time. Why don't you just put a no in memory hint in there and be done with it?
Okay. Then make no in memory.
Even if we tell it not to use the column store, Oracle's still smart enough to say, I want to use the column store because it's so much faster. So
no fake with the database. memory. Save. You see, I'm not.
I don't know why your ultra session. Oh, I know why the ultra session command didn't work, because that script reconnects to the.
Yes, we reconnect. Yeah.
Yeah, because it gets the statistics fresh every time, so that it's not cumulative.
Yeah.
So that's why.
Yes.
Anyways,
no, it's longer.
Yeah. There you go. 1.13 seconds without the column store, and 0.3. So it took a full second, which is like 3 times slower in our small environment, granted.
Exactly.
For 4, well, so the trade-off is that you lose 0.2 of a second for 4x more memory, but if you didn't have the column store at all, it would take 3 times longer. So the trade-off is noise. I mean, that's like, it's for a lot of customers anyways. Now, certainly if you're talking queries that run in minutes or hours, then the difference might be a little bit more. But even then, to gain that additional memory capacity is I think pretty compelling. It's a pretty powerful message. It says,
it's still significant faster.
Right. Yeah. So really, the capacity high, capacity low, the higher levels of compression from the default are really things that customers should probably look at, especially if they're memory constrained, and that means they can fit twice as much data in the column store than they could otherwise. So pretty great. So not only is it not 2x, it's way less than 2x, right?
Yeah.
So good. That's pretty cool. I don't know. I don't see any questions. If anybody has a question, please go ahead and type it into the chat. Do you have anything else to talk about, Markus?
Yeah, I would like to point to our additional resources, to our, let's say, white papers, our videos, and the memory block, especially to our DBM resources. And there you can find a summary of all technical informations, videos, also hands-on labs we used in this demo. And I would also like to mention that we have used when we have a comparison in our hands-on lab between buffer cache and the memory column store. We have both completely in memory. That means we pin the table to the buffer cache with in the key pool, so that we have a more realistic, let's say, comparison, that we compare apples with apples. In our example, we don't cache anything, because otherwise we wouldn't see this effect that we need not much space for the columns for running queries in memory column store. So just to point this out, when you do the hands-on lab, we keep the data also in the buffer cache. From line order, and then we pin 150,000 blocks in the when you run the VH query I showed you, the blocks in buffer cache, then you have 150,000 instead of only 10 or 15. This is only an insight.
Right, but the motivation there is just to show that columnar memory. Or the memory used by the column store is queries there are much faster than even if the full table were to be cached in the row store, right?
Exactly.
But that's of course not realistic, because why would the whole point of the row store is it only caches the blocks actually needed for OLTP workloads. So now you get the best of Oracle's database's abilities between the row store, caching in the buffer cache for your index query that you ran, and then any analytic queries where we're scanning all the data goes to the column store, right? So that's kind of the takeaway there.
Exactly. Yeah. Okay, then I think all is set. We don't need twice memory. we are very efficient. Yeah, we have this in-memory compression ratios different, to save more memory. Yeah, and yeah, I think this is a good point to know.
Right. So last chance for any questions. We'll hang around here just for a minute or two longer. But if not, I think that's a great demo, a great way to prove some of our critics wrong, that it doesn't require twice the memory. Matter of fact, much less than that. And we get phenomenal speed up from both the column store, and then the row store and OLTP workload remains unchanged. And you don't have to change the SQL, right? Other than having to put a hint in to tell Oracle not to use the column store because it's so much faster to do that.
Exactly.
That's a great session, Markus. Thank you to everybody. It looks like there aren't any questions, so thanks to everyone for joining us today for our office hours session, and we'll see you next time.
Yes, thanks a lot. Bye.
Bye.